Welcome back, learners. As you know, in the previous session, we have discussed about how to categorize the column into heavily loaded columns, medium loaded columns, and the low loaded columns, right? Based on the number of beams going to connect to the given column, out of which how many number of beams are the primary beams, how many number of beams are the secondary beams. Based on that, and even the amount of the area of the load from the slab that the given column receives. Based on all these categories, we have decided that some of the columns are the low loaded columns, some of the columns are medium loaded columns, and some of the columns are heavily loaded columns. Now, once the column loadings are decided, our next step is, as I already told, we have to decide the shape of the column. Now, usually under the special circumstances only, some different type of or the shape of the column will be considered, or sometimes for the architectural purposes only, some special shape of the columns are considered, like hexagonal shape or octagonal shape. Like that kind of columns are considered only for the architectural purposes. Okay, for the normal construction of the columns, usually the columns that we are going to consider are the rectangle, circle, or the square columns, because casting of those different shapes of the columns plays a very significant role, where it costs very much higher. Okay, so that's the reason we, until and unless there is a requirement for the architectural purpose from the client, usually we never go for such kind of shapes of the columns. Now, the most common three types of columns are usually the circular column, or the square column, or the rectangular column. In that, again, usually we ruled out the circular columns, because again, for the sake of casting of those circular columns, because the casting of circular columns needs the special formworks. Nowadays, there are a very good formworks are available, which are made up of completely the fiber, which is very durable and very strong. So therefore, casting the circular columns also has become very easy. Otherwise, the most conventional methods of the column shapes are the square and rectangle. But still, compared to those two, usually the most common type of column that we everyday see is the rectangular columns. You may have the question, why is it so? Usually what we do whenever we do the rectangular column, the one side of the column, the dimension of the one side of the column, we call it as the shorter dimension. Another side we call it as the longer dimension. For example, if I consider a rectangular column like this, okay, if I consider a rectangular column like this we are going to call that as the shorter dimension of the column, whereas these two we are going to call that as the longer dimensions of the column. Now, the major advantage of having the rectangular column is the shorter dimensions of the column will be made in such a way that the dimension of that shorter dimensions of the column will be equal to your wall thickness. Okay, the dimension of the shorter dimensions of the column will be made equal to the wall thickness. Why it is made so? When the dimension of the shorter dimension of column becomes equal to the thickness of the wall, there will not be any eccentricity. For example, if this is my column, so I can easily construct my wall like this. Okay, I can easily construct my wall like this. Usually, the thickness of the wall that we usually maintain after plastering is around 9 inches. This is the most common thickness of the wall that we usually consider, 9 inches. Usually it comes around 7 inches. If you are using the cement concrete hollow blocks, it comes around 7 inches. So 1 inch plastering on both sides will give you a 9-inch wall. So therefore, usually what we do, in order to maintain the in order to avoid the eccentricity, for example, if I am using any square column, then what will happen? If I maintain an 9-inch wall, then definitely it leads to some eccentricity like this. Okay, it leads to eccentricity like this. So usually this kind of eccentricities or the corners will not be accepted by the clients because it is a dead area where you cannot utilize it properly. So that's why usually exceptions will be used, where usually when you go to the very large or the huge commercial buildings, okay, where a large or the huge commercial buildings, there only the square columns are preferred. There you will not be having the problem of walls, because when it comes to the commercial buildings, the architectural importance is given least preference, means it will be given but little bit of more will be provided for the occupancy purposes. Okay, there will not be much architectural specialences in the public buildings. Whereas when it comes to the residential building, the client will be very specific with respect to architecture, where we cannot compromise at all. So in such cases, usually we provide the rectangular column only. We usually won't go for the square columns. Okay, and the one more condition that where we usually go for the square columns is if your plan of a building is also if it is of square in nature. That is, the dimensions, the overall dimension of the building in the longer direction, that is x or y direction, or in the shorter direction, that is x or y direction, almost they are same. That means you are maintaining the length to breadth ratio of almost equal to 1. Then in such cases, again we can go for the square columns. But if the overall L by D ratio, that is length to breadth ratio of the plan, is of very larger value, it is very less than 1, or if it is more than 1, then we won't go for usually square columns. You may have the doubt that why is it so? There the concept of the moment of inertia comes into picture. For example, I am drawing one column like this, which is a rectangular column, okay, and I am drawing one more column like this, that is also again a rectangular column like this, and I am drawing one more column that is a square column. Okay, I am drawing a square column. Now when I take this as my reference, when I take this as my reference point, okay, when I take this as my reference point, now if I see here the moment of inertia of a rectangle, it is B dq by 12. Now I am going to consider this as B and I am going to consider this as D. Okay, I am going to consider this as B. Okay, I am going to consider this as B and I am going to consider this as D. Now when I make B dq by 12, definitely the B value is higher, and when I write B dq by 12, the depth is considered thrice, that is cubics. So here the depth value is much more lower than the breadth value, therefore the value of I will be lesser. But if I take this, then definitely this will be my D, this will be my B. Okay, when I rotate like this and when I keeping this as my reference, this will be my D, this will be my B. Now when I calculate I, that is the moment of inertia, okay, the moment of inertia, then the D, since it is cube, definitely the D value is higher, therefore the value of I get is much more higher. So this option is available only, or it is possible only in the rectangular columns. Just by changing my orientation of the columns, I have a freedom to increase the moment of inertia of the column. Okay, but that option is not available in case of a square column, where since square column will have both B and D same, so however you turn the column, your moment of inertia of the square column or even the moment of inertia of the circular columns remains the same. Because you know, for circular columns also it is pi d power 4 by 64. However you rotate, it is not going to change. Even in the square column also, however you change, it is not going to change. But changing the moment of inertia just by orienting the column is possible only in the rectangular column. Therefore, I can make the structure more and more stiffer just by orienting the positions of the columns. That's why in the beginning of my lecture itself I told you, orientation of the column in a given building plays a very important role. Now whenever we are going to model here, we will just first orient all the columns in one particular dimension. Then based on the beams, how many beams that a column is going to connect, that how many beams are primary beams, that how many beams are secondary beams, based on that we will again orient the positions of the column. So that option, since it is possible only in the rectangular column and so many advantages are there, we are going to consider the rectangular columns only compared to circular or square columns. Similarly, in this project also whatever I have considered, I am going to consider all the columns as rectangular columns only. Okay, so therefore now I told you we have categorized the columns into three parts. One is the high load bearing columns, medium load bearing columns, and the low load bearing columns. That is decided. It has been highlighted also. The second point is we have decided the even the dimensions of the column, whether we have to choose rectangle, square, or the circle. And even I told you the significance of the rectangle or significance of the square or significance of the circle. So therefore we have decided that even my columns are of the rectangle in nature. And next is we are supposed to choose the dimension. Okay, we are supposed to choose the dimension. So now I already told you in the rectangular column we will make one side as the shorter dimension, and making the one side as the shorter dimension, we make the dimension equal to the thickness of the wall, so that eccentricities in the wall will be avoided. So therefore now when I am making the three columns here, high, medium and low, my shorter dimension, all the columns that I am going to consider will be the rectangular columns. In that the shorter dimensions of the column I am going to make equal to the thickness of the wall. Now, as per the client's requirement or as per the architectural design, the wall thicknesses here are 9-inch walls. Okay, the wall thicknesses here are 9-inch walls. You can see only the partition walls are the 5-inch walls, whereas all the main walls are 9-inch walls. You can see here all the main walls, these walls are 9 inches, only the partition walls are 5-inch walls. Okay, the partition walls are 5-inch walls. So therefore since the main walls are of a larger number, so we will make the column dimensions of the shorter dimension of the column equal to 9 inches. By keeping the shorter dimension 9 inches, so now let us change the longer dimensions of the column. Okay, longer dimensions of the column. So now let us make the 3 columns now. So what are those? We will just make three columns here. Okay, I'll just write here. Yeah, so now what I will make is, first I will give column number 1. So column number 1, I'm going to consider a low loading columns. So I told you the shorter dimension I'm going to keep as it is, therefore I'm not going to change 9 inch multiplied by another longer dimension also. I am going to make it as 9 inch only. First column, that is low load bearing column, I am going to make it as square column of 9 inch by 9 inch. Okay, square column of 9 inch by 9 inch. That is my first column. Okay, so it is my square column of 9 inch by 9 inch. Okay, right? Okay, it is of 9 inch by 9 inch. Now I have another column which is an medium load bearing column. Okay, so that what I will do, I will make it as a column number 2, and I am going to make that column shorter dimension no change 9 inch, longer dimension I'm going to make it as 1 feet. Okay, longer dimension I am going to make it as 1 feet. Okay, okay, it is going to be 1 feet. Okay, it is going to be 1 feet. Then this is usually we will consider it for the medium columns. So then when it comes to the higher column, let us assume that column number 3 I am going to make, and I am going to make that as shorter dimension 9 inch by, I will make it as, usually we will keep it as 1 feet 6 inch. Okay, so 1 feet 6 inch, that is it comes around 500 mm. So I will make it as 1 feet 6 inch. Okay, so these 3 are my column dimension. Okay, that is column number 1 9 inch by 9 inch, which is a square column. Column number 2 9 inch by 1 feet, which is a rectangle column. And column number 3 9 feet by 1 feet 6 inch, that is again rectangle column. Okay, so we have assumed the preliminary dimension. Whatever these dimensions are there, they are the preliminary dimension. Okay, they are the preliminary dimension. Okay, okay, so this is the preliminary dimension. Okay, this is the preliminary dimensions of the column. So like this, now we have assumed the preliminary dimensions. Now once the column dimensions are decided, my next step is I have to decide the beam dimension. Okay, so in the next video I will explain you how to consider the preliminary dimensions of the beams. There are some criteria to be understood, that how we have to consider the preliminary dimension. So once I explain you the consideration that we have to do in choosing the preliminary dimensions of the beams, and once we decide the preliminary dimension, Then we will start modeling in the software. Okay. Thank you, learners. We will continue in the next class.